Todd, it's wonderful to have another individual from Magna on the road to autonomy. To kick things off, I have to start with the nomenclature. When somebody says AI in manufacturing, what does that mean to you? Because all individuals seem to mean different things to different individuals.
Yeah. Hey, thanks for having me, Grayson. I just sort of look forward. I'm sure we'll have an interesting conversation, right? And you started off, I think, right to that point, asking about AI. So AI in manufacturing. I mean, it's such a massive potential scope, and I think that's the starting point, of confusion. but where I come from, and I think about AI in manufacturing. What is AI? It's really just a tool set. It's another tool set, maybe a very powerful tool set, but it's another one we can add to what we already have. And what's it really good at? Well, making some decisions, looking at patterns, recognizing things that maybe are people can do or are very, very difficult for people to grasp and do, and making some recommendations and decisions. So sort of a great simplification, but that's kind of how I think about AI in manufacturing. And then you sort of go, well, what do I do with this new tool we've got, right? Where does this help us, and what can we do? Well, what it's really good at is bringing in different types of data in large quantities and sort of finding patterns and recognizing things that are a little tricky to see for people. And so, applications that we see right away, things like optimization. So looking at sort of flows in operations, et cetera, that have many, many different data points, many different types of equipment, machines that maybe historically haven't been fully connected, and now we can connect them, and we can use these tool sets to analyze and optimize performance ultimately. Some other sort of related but sort of classic areas where AI and manufacturing has come in is sort of coming out of consumer electronics and phones and games and the internet and these things. We have immense capability on computer vision. And what is that? Well, again, that's pattern recognition. That's sort of using AI to train models to look at pictures. And a picture can be a visual thing, but it could also be a representation of data in a different way, to pick out sort of information and say, hey, this is potentially a problem, or this is a good part or a bad part. So you think about in terms of quality, some large applications, but also in sort of analyzing different data sets and again, picking out things that we may not otherwise see. And then sort of, I guess, another big category I see in AI manufacturing is more emerging. And this is where, a lot of our team is focused on automation and robotics, right? Essentially applying AI to the physical world, which is robotics. And what does that mean for us? Well, it's really introducing more capability than we already have. We have lots of robots and a lot of automation today already in operations and highly capable. Where AI comes in, it lets us start to think about things in a more open way, so more flexible, adaptable. Can we train and learn and teach the robots, teach the machines to make decisions more like a person would? So rather than, historically we train robots, we program them. You start off talking a little bit about programming. Historically, we program things to do very, very defined tasks. It does exactly what you tell it, and maybe you have some logic in there. And in this case, you do this. In this case, you do that. With AI, we start to be able to introduce the capability for the machine on the fly to be looking at images or other data, make a change, and actually adapt what it does. And so that's working a lot closer to the way people work. So it's not you can't predict 100% exactly what it will do every time, but the machine is then able to, in this case, a robot, say, it needs to pick up a part and it needs to reorient it because it's not in quite the same place. So AI enables that ability to kind of do that work on the fly. And that will be, I think, a very large emerging opportunity for us, right, in the future to make more, increase capability of robotics, but also to add adaptability and flexibility to the systems. So they're, much more easy to deploy to different tasks, move around, et cetera.
Did you develop, or did Magna develop that AI brain internally, and did you customize it for your applications that are over in 28 countries?
Yeah, so Good question. I think if I think about an AI brain, or there's different types of AI models that are used for this. What's used in autonomous driving and VLA models or world models, etc. There's many variations of these. We don't build or create those initial models as a starting point. We're literally taking what's being done in the research community by companies and sort of other sectors and industries that sort of create those base models. Where we come in, of course, is those raw models typically aren't ready to do much or deploy, and so training them, adapting them, knitting them together with the robotics and systems using our know-how or our data. That's really the work we do.
Are you building those models on top of open source models and running them on-prem? And I ask that from a data sovereignty security perspective.
So yeah, good questions. There are many open source models, and there are many that are not. We have to be sort of very, very careful, of course, in how we handle and manage that for a variety of reasons. Sort of data security, et cetera, is a key part of that. So what happens if we end up taking an open model? It's not going to be open by the time we work with it and deal with it. It's going to have to be secured and closed off. So in a strict sense, I say it's not actually open anymore at that point. But the open models may be used as a starting point, as long as we can bring them in and secure all those, fulfill all the requirements to make it secure and safe.
Requirements is the tricky part, because Magna has manufacturing facilities, as I said, in 28 countries. And obviously you have different customs, different norms. You're building different things at your factories and your facilities. Do you have to customize the model per factory or per region, just because of, say, like compliance purposes?
So again, it would depend on the nature. So many, or even most of the models, et cetera, we're working with right now, for instance, if you're looking for, say, quality, so defects or anomalies in a part or something, yes, there might be proprietary information for Magna in there, but you're not really doing anything that would relate to say privacy or employee or people's sort of needs, and so it's relatively safe. Of course, it has to be checked, right? So in every jurisdiction, you have to consider what the jurisdiction says and what those laws are. Just like what we do in every other manufacturing facility. If you bring a robot into the U.S. versus Canada versus Germany, right, you have local authorities you have to deal with, and so we have to think about that in exactly the same way with data. That being said, in most of the cases we're dealing with today, it isn't an enormous issue. Where it becomes more of an issue, of course, is if you start dealing with anything that's more sensitive or more tied to people, right? And we tend to, I'll say, stay away from those topics. But if necessary, right, they can be handled, but you have to handle them more locally. But a model that can find a defect in a part in Michigan can probably do the same thing in Germany. There might be some tweakings and adjustments, but it's more to do with like the local, say the customer, the part, the specifics of the machines, etc.
From let's just say a technology holistic standpoint, how do you make the decision of what advanced technology each factory is going to get?
So the way we think about this, as you said, we have a lot of facilities, we have a lot of processes. So if you think about rather than necessarily just the product, it's also about the manufacturing processes used in each division. And so the way we think about this, we think around the lines of product or process archetypes. So what things are sort of common, and there's sort of major categories of those types of processes, and we sort of cluster the technology and align the technologies that support to those, and then that allows you to then think about, as you map across the whole organization, okay, who needs what's going to be most impactful? You have a stamping operation running these kinds of products. Well, you probably can use the technologies that support, picking and placing, handling these kinds of parts, as well as looking at quality, et cetera, on a stamp part or operating that stamping press. So there's commonality across that type of a thread, and so we have to organize our use cases that way, and then we also have to then organize our technologies and our solutions that way, such that it's manageable to think about, okay, what do I deploy, where, when? Then you get into how do I help the people on the ground, the plants, the divisions, their vendors, supporters, to actually do this, and that's where like a playbook approach helps, right? So a combination of some guides, some how-to manuals at a high level, but then also going deeper with examples, use cases. Who's done this? Who's maybe an expert? Who can you reach out to? What do I need to look out for? What needs to change? Because every process is slightly different than every other one, so there's always adjustments and changes that have to happen. But getting that clarity of understanding is sort of really important, I think, and helpful to enable scale.
If you go back to when Steve Jobs was alive and when Bob Iger acquired Pixar and Steve Jobs became one of the largest shareholders of Disney at that time, he advised Bob Iger to buy back the Disney stores from the children's company. And in Burbank, they built a prototype Disney store. And Jobs had a lot of say in that to really try and understand the customers. And obviously, the Disney stores went on to get revamped, and me personally as a dad, they got a lot better. Do you build that was a model store. Do you build model plans to try new technologies and then, no pun intended, ship that around the world or take that playbook and deploy it?
So do we build like greenfield plants to do just that? No. However, we have a couple of outlets, between us and sort of at a corporate level and our operating product group level. We have various R&D centers that give us some room to have a playground to set up some of these things off the operating floor, but very close and within the country, within the company, such that we can then deploy out of these development centers. But quite honestly, I think the bulk actually happens on the ground in the real manufacturing operations. So that's quite honestly, there's no shortcuts. When you're not living in the real world, the real environment at real scale, you don't find all the issues. You don't find all the challenges, and also, at least as important, you don't have the experts, the people on the ground who actually know the processes, the products, the systems that you have when you're doing something in an operating an actual operating factory. So that's I think the strongest way to do it. Now, of course, you have to always balance that with the level of technology you're bringing in, the level of effort required. Is it close enough to production that we're ready to do that development on the ground? But so a mix of all of those is I think the right way, and that's how we do it generally. Of course, you always got to have an eye on scalability, right? What do I do in this particular facility? What is common across the other facilities that is going to be relatively easy to scale and adapt? What is going to take some more attention and local effort, right?
Is scale the number one thing that you look for deploying new advanced manufacturing technologies across all the facilities?
I would say it's the most challenging thing. Again, I'm an R&D guy, so I work in technology every day, and that's my passion and interest. We are not really limited by technology, quite honestly. We have so much at our fingertips, so much that's potential and capable and possible. The real challenge is deploying at scale. How do you get these things out? So when you say challenge, the way I think about it is it's understanding what are the tools that are going to enable scale, right? It may be relatively easy to solve one thing in one place if I'm not looking at the bigger picture. But if I got an eye on the wider picture, what's common, what's not, what tools am I going to need? Because sometimes it's actually about not the technology itself. It's about the tool set that goes with it that's going to enable that scale, right?
How important in that line of thinking are processes?
Again, I'm the R&D guy, so I'm always sort of pushing the boundaries on processes. But when it comes to scalability and deployment, those processes are essential. It's what's going to make or break. And when that comes back to things, processes and standards. and are critical enablers. How am I handling my data? Which type of equipment am I using? How do I plug this in? What sort of IT infrastructure do I use? What's on the ground? And again, we're very large and diverse, and you have different geographic locations, et cetera. So there's never very difficult to have single standards. But they don't need to be single. You can manage multiple ones, but you want as few as makes sense for the use case and the application. When we come to like data, and if I'm going to use any algorithm, whether it's AI or not, to say analyze operations or data, critically important that data all looks the same, right? Because then I can port and adjust and bring those models from one place to another place, and run it with relatively small effort. If I don't think about that from the outset, and everybody does things a little bit differently in every location, then there's really no economy of scale. What I do in one place, I got to do exactly the same thing over again. So that's something that needs to be thought of up front, and that's a process.
Right? And then this is fun. I feel like we're playing the vocabulary game here, but I have to keep going. Simplicity. Where does that come into baking the cake?
Yeah, that's a simplicity. Look, I'm an engineer background, so you drive for the lowest possible simplicity that still works, right? So that's which is a little bit of an oxymoron, or a bit of a dodge to the question, right? Because sometimes things have to be quite complicated to actually function and work, but ideally the eye should always be on what's the simplest I can reduce this to and still be useful. You think about like models or a representation of a machine or a plant or equipment, et cetera. You want it to be complicated enough it catches all the major inputs and outputs and is useful in making predictions, but as simple as you possibly can, so it's easy to use and deploy and runs quickly. But we tend to, again, coming from R&D technology, we love to go to the really fancy solutions. Sometimes that's we got to push back on that a bit, challenge ourselves.
I'm sticking on it. Sorry, you said fancy. I'm going to say the word trendy. Humanoids.
Trendy? Okay.
Do they fit under trendy? Do they fit under practical? Where do humanoids fit in this dictionary today?
Okay, so I'll give you my take, my opinion, and again, coming from automotive tier one manufacturing largely. Again, I'm going to dodge your question a little bit because it's both. They're certainly trendy. No one can dispute that. The amount of attention and media, et cetera, going into humanoids is incredible and exciting, by the way, right? Amazing. The practical side of it, how much of that is useful to folks like ourselves in our world? Some of it. And I think the way we like to think about it, and again, we have several I'll say test cases, et cetera, where we're working with humanoid or human-like robotics technologies and capabilities to assess, because fundamentally we really need to understand the space well, because as I said, we may not need full legged humanoid robots in our factories. I mean, there's obviously some use cases where that makes sense, but it's probably not the vast majority. However, the technologies that make that work, multiple arms, the adaptability, the flexibility, the dexterity, that capability, the supply chain that builds out these robots, those things are incredibly important. So when it comes to how that looks in the future at scale in our operations, may not look like humanoids as we see them today, but that foundational technology and those pieces will be there.
I agree with that. And you look at that, you have the actuators, because I think about this from a humanoid perspective. If I look at the items that Magna builds, a lot of them are very bulky and very heavy. So I could see the bottom half of the body potentially being wheels or being some caterpillar-like system or tank-like system, because just basically pure on weight
and sort of energy efficiency, and there's a bunch of advantages to that. There may be some cases where you need something that really operates like a person. If I think about vehicle assembly and people get in the car and do things like that, very, very challenging things to do, and maybe a wheeled robot wouldn't do that. But the vast majority of stuff we have is you have a concrete floor. you can move around on it, right? And so wheeled bases, I think, are very practical for us. There'll be many other cases where maybe the thing doesn't even need to move, right? But you need, do you need one arm, two arms, three arms? The key point is that intelligence and that dexterity, that capability for the robot or the robot arms to be able to work together, coordinate, and get the job done, right? So all technologies that are related and necessary for the humanoid development to happen anyway, right?
When you're, I'll use the broad term, experimenting with this technology, do you experiment with it in a Magna R&D lab? Do you experiment with on an active factory floor? Where do you experiment with it?
So the more, I'll say, advanced or unknown technology we'll do in a lab. And you do that for, safety reasons, control, having the experts on site, et cetera. They tend not to run all the time, so you're running in sort of intervals at different stages, et cetera. So not great, not so easy to do in a facility, in a factory. So we generally start in the lab. And then when something's ready, maybe you move it to, offline in a facility and run alongside. And so you can, again, still have control and still manage it and assess, and then, ultimately move the technology right into a line. So that's generally how it works with things that are maybe a little bit more unknown and more out there, right? And then certainly humanoids and human-like robots are in that category right now.
I'm going to ask this because I'm going to read you a LinkedIn post from an excerpt that you wrote, but do you see the potential of newer technologies accelerating into the factories and into the manufacturing facilities? Because on LinkedIn, this is really brilliant. I'm going to quote you here, what you wrote, because I really liked it. You said, in quote, "A new generation of workers raised in the pixelated realms of Minecraft and the immersive environments of the Unreal Engine is entering the workforce with vital problem-solving skills shaped by gaming." You're right. You're 100% right about that. We both have children. We see it firsthand. Does that accelerate the adoption potentially of new technologies in the workforce?
It definitely supports it. And the only reason I hesitate there is because, quite honestly, I don't see a lot of resistance to technology adoption, almost regardless of demographics. So I would say that, the younger generation raised in that environment, it's almost like, why isn't it already here? There's an expectation that we're actually further along than we really are. Like there's an impatience, right? But not to say that, other demographics or people my age aren't also embracing it. I don't see a lot of resistance, quite honestly. It's maybe not lack of awareness sometimes, but so are the younger generation faster? I'd say they grasp the things faster because they live in this world. It's very, very natural, and they kind of assume it should be like that, right? So when they go into a facility or even in the office and you're working with tool sets and tools that we use every day, I would say the younger generation has been trained to have a very critical eye to how good these tools are and how people interact with them and how they work. And so the expectations are actually really high. We've trained a generation, right, to think this way. So I think it will accelerate adoption because they're just demanding and see the potential.
Was the Unreal Engine, do you think that was the big breakthrough for these kids? Because if you look at Tim Sweeney and the team at Epic Games made that Unreal Engine, no pun intended, is truly unreal what it can do.
Yeah, so I don't want to fixate on that particular sort of company and approach, but yeah, I mean, what you think about, you're getting towards photorealistic 3D environments that are interactive, and now maybe at least have the appearance of physics involved, and some environments actually do have full physics engines behind them, which when we start to go to connecting this to the real world, that becomes a really critical piece, right? Before, in the gaming environment, it all looked real, very, very real, which allowed people to sort of immerse and act, and so you have simulation of physics, et cetera, going on in the background. Now we need that to be good enough that it actually really represents the real world, and then we can we can move from one to the other, and that's what becomes sort of really, really powerful. So I think we've always had, well, for a long time, visual representation. You saw the evolution of video games, and the quality of imaging and graphics and the physics has just got stronger and stronger and stronger, so that now we're at the point where it's not solved, but many elements are solved, right? Where the real world will behave like these virtual environments says it will, right?
You could even make the argument, and there's been, I think it was MIT or it might have been Stanford, put out a paper about the competitive advantage that children have from being exposed to certain types of video games. If you think about that from a manufacturing standpoint or an inventor standpoint, they could have a potential better understanding to go and build things and implement things. Do you think that those papers are right, in your opinion, that gaming could be a competitive advantage for new entrants into the potential workforce?
Yeah, I mean, in principle, I think they're right. Again, I don't really have data to back it up. I just, I see, as I said, I'm involved with, various youth activities and robotics and sort of scouts and my own children. I see sort of how they work in this environment. It's fast. They learn really, really fast. They adapt really fast. And I think that's coming out of just being native to these digital environments for so long. So yeah, that's an advantage. They also, the world's at their fingertips, right? They see a huge variety of things every day. Another big advantage they have, so they kind of have this immediate sense of what's possible. I'll say good and bad. Sometimes they don't know what's exactly real and what's maybe purely virtual, and so that can be an advantage for the imagination to sort of push you along. But you got to obviously ground it too with where we really are and what needs to be done to make it happen. But I think it tends to promote more creativity, right?
It's a valid point, because going forward, you're going to have more advanced manufacturing capabilities. You're going to have new technology. You're going to have vision technologies and these things. You're going to have more robots. Do the factories and manufacturers in the future, does the design have to change? Does the IT infrastructure have to change? Because you're putting all these new, I'll put it, superpowers, that's what they are, into these facilities, because you're accelerating. Does the design change, or anything have to change for these facilities to truly embrace it?
Well, it's evolutionary, I would say, almost, right? There's a continuous investment in, at least for us, and I assume others, of sort of the supporting infrastructure that makes all this work and happen, and that's just constant. As we add more and more technology and compute and capability in robotics, the technology, the infra layer that supports that has to grow at the same time. It evolves too, and this is where it's really important to sort of set those standards and have those processes in place, that whatever we do today, yeah, it's not going to last forever. We're going to build on it, but you don't want it to be wrong. You want it to be able to support what's coming in the next years. So it's sort of a continuous sort of effort and build. But does it fundamentally change the factories? I think ultimately it will. As we get sort of more and more of these sort of systems, automation solutions, analytics in the factories and in place, what are you doing? You're identifying waste. You're making things more efficient. You're sort of accelerating, and so that feedback loop will also kind of redesign the factory as it goes, right? As you solve problems and you improve things, then you realize maybe some things aren't quite necessary anymore, and you adjust and you change. And the history of our industry and Magna has been just constant, steady improvement in quality, but also throughput, output, cost of manufacturing. Generally drives down over time, and I've been in the industry almost 30 years now, and it's been continuous the whole time I've been here. And I think these tools are, if anything, they just maybe accelerate that a little bit further.
So all the data that you're gathering from all the factories around the world are constantly going, let's just call it the Magna model, are going in to improve the model, increase efficiency, build better and better products. Is that where all that data is constantly going back into that Magna model?
So, I mean, it's obviously a really complicated environment with we have so many customers and products, etc. So you have to sort of manage that in terms of proprietary information and customer data and products, etc. So that needs to be sort of secured and looked after. But in general, on like more general operations, if I think about manufacturing processes, whether welding and stamping and molding and coating and those kinds of more general processes, yeah, we can collect that, we can feed that into sort of our overall models and use that to improve the operations. As I said, they're all unique. There's variations, but it's still helpful to be able to collect the general information and then use that and apply it in different ways to different processes, operations, right? A little bit of a flywheel going there. As the more you bring in, the more you can connect, the more data you get, the more you learn, and the better you get, and then we can sort of apply that individually on products and or processes. Ultimately, yeah, that'll go to the product side too. We have some examples, I think, of sort of where that's starting to happen, where the feedback from the data and the factories is getting fed back, and historically it was called design for manufacturing, which you'd bring into the engineering world. So that's always been there. These tools just again accelerate that. They just increase the data, the bandwidth we have for design for manufacturing.
The one thing throughout Magna's history has been a consistent focus on quality, and that continues to this day. Magna plays a very important role in the automotive ecosystem and in the autonomy ecosystem, and the curiosity hat's on, because I don't know if you can comment on this, but I'm still going to ask because I'm curious. Do we ever get to a point in the future where Magna, I have to use the word potentially because we use the word potentially, ever builds a Robotaxi factory for either dedicated for one customer or multiple customers?
Well, so again, I'm on the technology R&D side, but look, we support all of our customers, and if you think about sort of who our customers are, right up from tier 1 and tier 2, tier 3 component manufacturer all the way to full vehicles. So let me put it that way. I think if there's a market, if it supports our customers, then it's definitely something we look at and consider. I think the auto industry is evolving and changing, and we have a number of adjacent products, for us, like heavy truck or like Class 8 truck, et cetera. We don't consider automotive, but it's adjacent, right? There's a lot of common capabilities and interests, and there's some other markets like that too that we naturally support and go to. So for me, the Robotaxi question, it fits the same model.
I like that. We'll go back to the dictionary. I could file that under possibility. We've had all sorts of words in this dictionary today. And Todd, this has been a fascinating conversation. And I love to know, before we wrap, what is the future of advanced manufacturing at Magna look like?
I think we touched this topic a whole lot. It's about data, right? At the end of it all, it's about data in our operations, and then making that useful and sort of using that to make us better and better and better. And that never ends. That quest goes forever. We will keep improving. And the more data, the more tools we have to then apply to that, the better we become. And what does that look like? Yes, there's more automation, but there's also a lot more, I'll say, higher level skill roles. If you think about how you run that, how you manage it, how you develop the people and the teams to use that. Again, come back to this tool analogy. These are all just tools that make us better, but you need the people, the workforce, the capability and knowledge, the skills to be able to use them and do that.
At the end of the day, there's a consistency. Magna has continuously manufactured great products. And as Todd said, it's all about the data. The future is bright. The future is autonomous. The future is Magna. Todd, thank you so much for coming on the road to autonomy today.
Okay, thank you, Grayson.
Billions and soon trillions in value will be created in the autonomy economy. By the time a trend becomes consensus, the alpha is already gone. The gap between uncovering signals and reading headlines is widening fast. When it's a headline, it's no longer a signal. Enter Autonomy AI. We decode signals before they move markets, giving you conviction in the autonomy economy. Autonomy AI. Your models, our intelligence. Visit AUTNMY.ai.